Alright, here's another problem from Alex. This is going to deal with molarity and molality and some of the differences between the two. So a student dissolves 2.7 grams of urea in 150 mils of a solvent with a density of 0.090 grams per mil. The student notices that the volume of the solvent does not change when you add the urea to it. That's not always going to be the case. But then it says calculate the molarity and molality of the student's solution, and remember your sig figs. Alright, let's just talk about some definitions real quick, because that'll help us here. We have what is known as a solution. Okay, and a solution consists of a solvent. Often it's water, but not always, but solvent. And it also contains a solute, something that we dissolve in. Usually we can weigh that out, often we can. So a solute and a solvent equals a solution. Okay, so molarity, the big M, as you guys already know, equals moles per liter. And that's per liter of solution. The little m, not a big difference, but that's big M, this is little m. Molality is going to equal moles per kilogram of the solvent. Okay, so it's not the solution, it's going to be the solvent. And so in order to get that solvent, we'll have to take the solution and subtract that, the grams of the solute. That's kind of what we'll be doing here. Alright, so let's tackle this. We know that for both molality and for molarity, we need to calculate moles of urea. So let's just start over here. We have 2.7 grams of urea. And I need to get that to moles, and we've done that a lot. And so let's do that. I know, as I looked that up, that there are 60.06 grams in 1 mole of urea. So it's a very quick and short conversion here. So if I do that math, I know that there are 0.045 moles. Okay, so that is how the moles of urea that I have right here. Okay, so molarity is going to be easy. Remember, molarity is moles per liter. Here's the volume that I have, 150 mils. So let's just convert that into liters. So I have 150 milliliters, and I know that there are 1,000 milliliters in 1 liter. So when I do that math, I have 0.150 liters. Alright, so now for molarity, let's do that one first. Molarity is going to equal 0.045 moles, and that's going to be per 0.150 liters. I just took this value and put it there, and took my volume and put it right there. And when I do that math, I get 0.30 moles per liter, or molar. I just calculated from this problem the molarity. I also have to do the molality. Remember, molality is going to be moles per kilogram of the solvent. Well, I don't know the mass of the solvent, of the solution itself, okay, but I can calculate the mass of the solution by using the density. Okay, so I know that there are 150 milliliters. That's what the problem tells me. And I know using the density, sorry about the crooked line, that there are in 1 milliliter, there are 0.90 grams. So when I do that math, then I calculate that there are 135 grams of the solution. Right, but remember that solution solution equals solvent plus solute. And since I'm trying to find the grams of the solvent, or the kilograms of the solvent, I'm just going to rearrange to say that the solvent equals the solution, the mass of the solution, which I calculated right here, minus the solute. Just did that algebra right there. So for the solvent, the mass of the solvent equals the solution mass, which I figured right there is 135 grams, minus the solute. Well, it tells us that urea is the solute, 2.7 grams. So I'm going to subtract 2.7 grams, and that will tell me the grams of the solvent. And if I do that, I get 132.3 grams. Now, remember, molality is moles per kilogram of solvent. We've got it to grams, 132.3. And so I know that there are 1,000 grams in 1 kilogram. And so that is going to equal 0.1323 kilograms. Sorry, I'm getting cramped in that little corner there. So it's 0.1323 kilograms. So let's calculate molality now. Molality equals moles per kilogram of solvent. Well, here's the mole. It's been sitting there the whole time. We calculated that first. That's 0.045 moles divided by kilograms of solvent, which I calculated right over here in that corner, which I know it's hard to read, but it is 0.1323 kilograms. And if I do that math, I calculate 0.34 moles per kilogram, or molality. So my answers for this are going to be molar, which is 0.30. A lot of things circled, so that's the one, that's molarity. And molality, which is moles per kilogram of solvent, we just solved for. Go team.